Hello.
So we are back.
And this time we're going to move forward learning how we can filter power rail. Yeah?
Filter.
Yeah.
Okay.
Yeah. Good. So what we learned yesterday? Just quickly.
We learn about diodes.
We learned about diodes and transformers, right?
And transformers, yes.
Okay. So this is our transformer.
Mm-hmm.
And we said we are using a rectifier bridge.
Mm-hmm.
Now you can, you can just use something like that. So here it's AC, here it's AC for a rectifier bridge, and here is plus, and here is minus. Now I seen people yesterday on. Someone said in the comments, sorry, actually it's wrong. The diode, it's opposite from what you are saying. I mean the plus is on the other side of the diode. And that's right. But when I learn it, I learn it like, where is the ring, there is the plus. So maybe this can be important, or anode and cathode, yeah. But actually it's not important. Actually you can see the diode as a duct, yeah? So it's a duct, so we know the current flow from the tail to the head, so it's not important. Plus, minus, anode, cathode, it's not really important. If you know the current flow is from the tail to the head, yeah? So, we have plus and minus.
Mm-hmm.
You know what I want to do today? I want you to be a power supply. Huh? What do you think? Can you be a power supply?
Oh, of course, I've got all the power. I can supply everyone
with
some power, yes.
So let's
magic power. Obviously.
Let's go one more time quickly, yeah.
Okay.
So our signal after the rectifier bridge, yeah, we see on oscilloscope, yeah. So that's the zero line, and actually the wave it's a little bit more like that. You remember on oscilloscope?
Yeah.
Like that. You remember?
Mm-hmm.
It was like that.
Yep.
Okay.
Mm-hmm.
Good. Now, after the rectifier bridge, how is the signal? So the signal must be like we have this shape and this shape. So we have this one and this one and this one. Yeah, this one, this one. So the signal must looks like, yeah, this is the zero, like that. Right?
Yeah.
Now we have to make those bumps straight line. Okay? Good. Now I want you to stimulate our signal. Our signal after the rectifier bridge.
Well, how do I do that?
Very simple. You have here the power supply. Yeah.
Okay.
5 volts should be okay.
All right.
So yeah, that's the power supply. That's minus. Yeah.
Mm-hmm.
And I want to touch the plus with this. But you try to keep touch it just to see if it's, we have light. I want to keep a constant frequency.
A constant frequency?
Yeah. You remember on the mains, the AC is like 50 hertz. That means 50 times per second.
Yes.
Yeah? So try to do it at least like 2 hertz. 2 hertz, that means the light comes on twice per second. Can you do it?
Like this?
Yeah. Yeah. But keep going. So this is quite like this is like 3 hertz per second. You can see? So what is happening? The light is coming on and goes off.
Yeah.
So indeed you are a power supply, yeah? With 3 hertz. It's DC, but 3 hertz.
Okay.
You understand?
Yeah.
Now, if you'll try to replicate and make it 50 hertz, that means you have to touch it 50 times per second.
Yes.
You understand?
I cannot do that.
Okay, but Even if you do it faster, you can see the light comes on and goes off, right?
Yeah.
Good. Now let's get a capacitor.
Oh, not again this one.
So now
not
we have a
again this one.
capacitor. No, let me help you.
Oh,
Let me
yeah,
help you.
of course, please.
So minus, minus, okay? Good. And then we have plus. Good?
Yeah.
So now we have a capacitor with our load, which is the LED.
Yeah.
Now I will hold the minus. So do the same thing, yeah? Like touch it, like 2-3 hertz per second.
Oh lol, it doesn't go off.
You see?
Yeah,
You see?
it doesn't-
That's what a capacitor is doing.
Yeah. It's holding a bit.
You see?
Yeah.
You see? Because the capacitor is charging,
Yeah.
and then the load is using the power from the capacitor when you are off. You understand?
Yeah.
And when you are on, you are charging the
Again.
capacitor and supplying the power.
Yeah.
So you see?
Yeah.
That's called filtering. Hopefully that's how it's called in English. But you understand now what the capacitor is doing?
Yeah.
Now think. Now you are still, just try again. You can still see something, yeah?
Yes.
But think, if you have there 50 times per second, you will
cannot
see
it.
nothing.
No.
Yeah, it will be like straight line.
Yes.
Yeah?
Yeah.
Now think, what about if you have 300,000 times per second?
You will not even notice.
Yeah, exactly. It will be
anything.
like perfectly straight line.
Yeah.
And also you can use smaller capacitor,
Yeah.
right?
Mm-hmm.
Going up on the frequency, because you're doing very fast, is no need for such a big capacitor. So that's why the switching power supply, they have a smaller capacitor.
God, they don't need the bigger one.
Exactly.
Yeah.
Because you see, they're touching very fast. So this, what we have on the main is 50 hertz, 50 times per second, yeah?
Yeah.
The switching power supplies, they have 300,000 times per second.
Holy.
So they are usually work with 300 kilohertz, which is 300,000 hertz.
Wow.
So now you understand how the capacitor are working? Great. Now is something more important. Let me grab the transformer. Now, before we are using the capacitor, yeah, so we have the transformer, we have the rectifier bridge to change the AC in DC.
In DC.
And we have to connect the capacitor to straight the DC, yeah?
Yeah.
Good. I want to check the voltage here, just to see the voltage before we are connecting the capacitor.
All right.
So we have the multimeter, yeah.
A plus and minus.
So what's the voltage?
It's 11.8.
But you can keep in mind this?
12. It's 12.
Yeah, you can keep in mind 12.
12, okay.
Yeah,
Yes.
good.
Yeah.
Now let's solder the capacitor. I will unplug the transformer. So solder the capacitor. Be careful, minus with minus. Yeah. Good.
This is minus, right?
Good. Yeah. And plus with plus. Good. Perfect. You sure this is the right capacitor? Did you check the voltage?
I don't know.
The voltage of the capacitor? Remember I told you?
Yeah, it was saying on this one, it was 63 volts. 63 volts, 4,700 microfarads.
Okay. So I will plug the transformer.
Okay.
The transformer is plugged.
Mm-hmm.
Now you have to be careful because this is an unprotected circuit.
Okay.
So if you spark this, the rectifier bridge, it will blow up.
Okay.
Yeah?
Mm-hmm.
And it will be like a big spark.
No, I don't want that.
Okay, so let's check the voltage now.
All right. So, plus.
Yeah.
Okay, and minus.
Yes. What's the voltage?
17. It's go up with 5 volts.
So why we have 17? You checked and you told me are 12 volts.
Yes.
And now you tell me are 17?
So wait a second. Does mean this one amplify the?
No, it cannot amplify. It's a capacitor. There are two plates. You understand? It's just a capacitor. It's like a battery. A battery is amplifying something.
No.
So we are speaking about voltage. You have a rise in voltage.
Yes.
So from where is coming the extra voltage? Like 5 volts.
5 volts. Yes.
Yeah. From where? From where is coming? Because you checked and it was 12.
It was 12, and now
Yeah.
it's 17.
So how there are 17? This is a dumb thing, you know. It's not amplifying anything. It's like a battery. It's storing energy.
Why you call that dumb? Sorry.
Because it is. It's a simple device. It's a simple component, electronic component.
Okay.
So why we have 17 now?
That's a good question. I don't know.
Okay. I'll show you why. But the next question, what I will ask you, you have to answer. You know, I will not help you anymore. Okay? Good. So we use a capacitor plus, minus, and that's the capacitor, right? Okay. So what a capacitor is doing? Like a capacitor in general, what is doing?
It what's it called? It's accumulated
Storing.
storing.
It's storing the energy,
yes,
right?
Storing. Oh my God!
It's storing the energy, storing voltage, current. Yeah.
Yes.
That's what it's doing. It's like a battery, right? That's what it's doing. Good. So what is storing?
It's storing the volts.
Okay. And the current.
And the current.
Energy, basically.
Yes.
Yeah? Power.
Yeah.
Remember what I told you when we test with one diode? You remember?
Yeah.
The voltage was like 5 volts, and you asked me why. You remember?
Yes.
And I told you know what? You remember I told you, you get only the top ones, and you have breaks. Yeah? So those breaks, because you were not catching the bottom one, yeah? And I told you, see, those breaks, it will give you a different average voltage. You remember? And I said, you know what? The average voltage probably is about here, so that can explain why you have 5 volts. You remember? Now, what the capacitor it will do? What the capacitor it will do with the voltage?
It will store all the.
It will store everything.
Everything.
Even
yes.
so, this is the peak. Yeah, that's how it's called, peak. You see this spike on the top?
Yes.
Peak, and it's not usable. It's not usable because it's very short. You can see. So the distance, this is very short. So you see, still here, you still have empty spaces like this. Yeah.
Yeah.
You don't have a line here. You have empty spaces, which it will give you like a usable average power, like about here. But not the capacitor. The capacitor, it will get the spikes.
Okay.
You understand?
Yeah.
So you have 17, but as soon as you use a load, and you ask for some current, this it will drop to about average. You understand?
Yeah.
You understand what I mean?
Yes.
So you have some voltage there, you're like 17, but this is not really that much current because those spikes are short from here, from the top. You understand?
Yeah. So as soon as you use some.
Yeah, the voltage it will drop.
It will drop.
Yeah. It's called RMS, but trust me, you don't want to calculate. You don't want the formula to calculate this.
Okay.
So you understand? For me, I'm happy just to understand. Because you think you have 17, yeah?
Yeah.
Okay, so we can use 17. But as soon as you start, you add a load here, and you'll see the voltage, it will drop, like a light bulb.
Yeah.
And you'll ask yourself, why?
I understand.
You sure?
Yeah.
So you can keep in mind 17?
Yeah.
Yeah? Good. Now let's add a light bulb. So let's connect a load, yeah? What about the LED?
Yeah.
Let me do it for you, because I don't want to solder this. And it's possible the capacitor to still be charged. I unplug the transformer, but can be charged. Yeah, you can see it was still charged. Okay, so what I'm gonna do, I will plug it and I want to check the voltage. Can you do it?
Yeah.
Good.
But there you go. Ooh, that's...
Yeah, the resistance is too low. Okay, but check the voltage on the capacitor, right?
Yeah.
So what is the voltage on the capacitor?
Plus, minus. It's 15.
15.6, you can see.
Yeah.
The resistance is smoking.
Yeah.
Yeah, that resistance is too low. Actually, the resistance is not only too low, but the power of the resistance is too low.
Yeah.
Because this LED can take probably like 2 amps. So how much voltage it was?
It was 15.6.
It was 15.
Yeah.
Okay. So the voltage just dropped.
Yes.
You understand?
From
so you are coming
17?
with a load.
Yeah.
So you understand why?
Yeah.
Because the peak is not usable. You understand? Good. Now let's connect the light bulb. Okay, so let me connect the light bulb for you. Let's see, maybe it's getting burned. We don't know.
I don't know. I think you know.
You know, because I told you what is happening when you're coming with a load. I already told you. We have the light bulb there. Let me plug the transformer. Huh? It's working. It's not getting burned.
Yes.
So check the voltage.
It's not 17.
Ah.
Yeah.
So what voltage it is before you are checking?
So the LED
Yeah.
was like 15, right?
Yes.
But the LED is taking just a low amount of current.
Okay.
So this one will take bigger amount. That's mean it will be lower than 15.
Okay, check. Let's see what voltage do you have.
I don't want to touch anything than this. Oh, I touched the bulb. You see? It's 14.
You see? 14 volts. So the voltage goes even lower.
Even lower. And if you put
Bigger?
it will
Goes even lower.
Even lower, yes.
Now, here, it's like complicated. It's not complicated. But you lose, current because of the wave shape, So actually you get, like how I said, you get the average from the wave shape, You don't get the peak.
Yes.
Good. Then you are losing some current. So check here. This is like warm now. You're losing some current on the rectifier bridge, Then you are losing some current into actually the coil of the transformer. So the transformer, it will get warm. Check the transformer resistance. So it's 0.8, 0.7, yeah?
Yes.
Okay, touch them together. And we have 0.5. So actually, the transformer has like 0.2 ohms, right?
Okay, yeah.
So you see, it has a resistance. And whatever has a resistance, whatever has a resistance...
that means lose power.
Yes, basically lose current. Yeah. And on the same time, the current, it will be exchanging... Heat. Yeah. So, the transformer, it will get hot. The rectifier bridge, it will get hot. Even the wires, it will get hot.
Even the bulb, because I touched the bulb.
Yeah, but that's the load, That's not the point here.
Okay.
The point is from where, from this point there, where you are losing. You're losing everywhere.
True.
So a linear power supply cannot be used like that. Because you design a schematic for a specific voltage. You understand? So I designed the schematic for 17 volts. And when I connect the load or whatever I want to supply the power, the voltage will drop.
Yeah.
That's why the linear power supplies, they are used with regulators. Yeah, voltage regulators.
Oh.
Yeah.
That means at the end you will have the same amount of voltage.
No matter what is the load or what is the input voltage.
Yeah.
You understand?
Yes.
I'm happy if you understand. What about we can build a regulator?
Build a regulator?
Yeah. What do you think?
That means it doesn't matter what you have here, you will have the same voltage at the load.
Exactly. It doesn't matter what load I will have exactly the same voltage here.
Yeah.
Yeah?
Mm-hmm. How you can do that?
You can do it however you want. Okay, so let's design a regulator. Yeah?
Mm-hmm.
Okay, so that's our schematic.
Yeah.
So how we can regulate the current on this circuit?
No idea.
No idea.
Mm-mm.
What about using a transistor? So let's use
3 legs transistor.
Exactly.
Yeah.
So let's use a transistor.
Okay.
Yeah. And here, what pins we should have?
So that's the.
So this will be a NPN transistor, yeah?
Yeah.
Where should be the collector and where should be the emitter?
All right. The collector is that one.
This one?
Yes. That's the.
This one is the collector.
Yes.
Yeah.
And the other one that's the emitter.
Exactly. That one is the emitter.
Yeah.
Exactly. So finally, I'll have a here plus. And here I will have minus, right?
Mm-hmm.
Good. Minus. Yeah?
Uh-huh.
Now, okay, this can drive the power, okay?
Yes.
But we need to manage the base. So on the base, we need like a precise voltage, which it will be constant no matter what is happening with the voltage on the input or with the output.
Okay.
So, what you are using to get a precise voltage?
A resistance.
Yeah, but if I connect a resistance, yeah, the resistance will change the voltage based on the input voltage, right?
Oh.
We spoke yesterday about a reference voltage.
Yeah.
So what we can use?
A diode.
A Zener diode.
Zener diode.
So if I connect the base, yeah, to a diode, right?
Mm-hmm.
Here I should have a precise voltage depends on the diode, yeah?
Mm-hmm.
The problem is we have no voltage here. So we need some voltage. And I said, you know what? In order to not burn the Zener diode, we can use a resistor. And obviously we have to take the power from here. Because here it will be no power if this transistor, it will not drive the power.
Yes.
Yeah? So if I connect on the resistor here, okay, so we have the resistor. We have the Zener diode, which it will send to ground anything over the diode value. And here on the base, we have a precise voltage. Yeah?
Yeah.
That means on the output of the transistor, we're going to have a precise voltage.
Yeah.
Yeah? No matter what, it will happen with the input voltage. So tell me what you didn't understand.
I do understand, yes. I said we're going to put the resistance, right? Or the resistor there before.
So if we'll be removing the Zener diode, yeah?
Yeah.
Nothing will happen on the output.
Yes.
I mean, nothing. The voltage, you know what? Maybe you will remember. Listen, we did these schematics. But our schematic was like that. Okay, here it was a light bulb, but the light bulb wasn't the collector. You remember? And here on the base, we use like adjustable resistor. You remember?
Yeah.
Like that. And here connect to ground and this to plus.
Yeah.
And we were adjusting the output light. You understand? But if you have like input voltage is changing, the output voltage, it will change.
Obviously.
You understand?
Yeah.
That's why we cannot use something like that.
But in order to not the output to be changed, you use a Zener diode.
We are using a Zener diode, exactly. Zener diode and a resistor to bring some current into the Zener diode. Yeah? So what do you think? Can we do that schematic? It's complicated?
Not really. No. Oh, it's not.
No, you see? Easy.
Easy.
Let's do it.
Easy.
So just to, make the thing simpler for you, we're gonna build the schematic on the capacitor.
On the capacitor?
Yeah, on the capacitor. Yeah. What's the point? Using the board, soldering it's just waste of time. Let's build this. You need 3 components. You need the transistor, the resistor, and the Zener diode.
Yeah.
Easy.
Yeah? Yeah, bring them up.
Bring the what?
The resistance, the Zener diode, and the...
It doesn't work like that. You have to pick up the components.
I have to pick up the components.
Yeah.
I thought I'd make like this and components shows on the table.
Yeah. So we have a bigger transistor. Bigger transistor means?
Bigger transistor.
Okay, what does mean?
That means he can carry more current.
Exactly. But say it like with confidence. You know what I mean?
Confidence, yes.
Okay.
I don't know how to choose my words. Okay.
Good.
Yeah.
So let's take this out. Okay.
Yes.
Let's solder the transistor to the capacitor.
All right. So we said the middle one is the base.
No, we didn't say that. Maybe it's good to check.
It's good to check. Okay. Wait. No. Yeah. Wait a second. It's not. Wait. I think it's the middle one is the collector, no? Because this has the...
Exactly.
The thing.
So where the collector has to be soldered, let's check the schematic.
So the collector has to be soldered on the plus of the diode.
Which diode?
No? Wait. This one.
This is not a diode. This one is not...
Not a diode, sorry. Oh, so many terms. This is the capacitor.
Good.
Yes. Good. On the plus of the capacitor.
Okay,
Sorry, I said that.
You have to be careful with this kind of mistakes. I was nearly to say, if you tell me that one is a diode, I will divorce.
I'm sorry. I can do that next time. Yay. Okay. So the collector must go here.
Yeah, I say, just let's make some space, you don't think?
So?
What about soldering on one side? Just to be sure we are not shorting anything. What about like that? Okay. It's quite far from the minus, right?
Yes.
Yeah.
Yeah, okay.
Good.
All right.
The next one is the resistor. Now you can calculate the current which you can check the Zener diode specification, yeah?
Okay.
And you can see the current based on what current has to flow through that diode. That's how you choose the resistor, yeah? But it's no point. We are learning repair, so I will tell you the value of the resistor. So let's say 470 ohms for the resistor, okay?
Okay.
Good. We can't see.
Oh, it's saying right here.
Okay.
470.
Okay.
this one.
Now the problem is you're not sure which is the base and the emitter because the resistor has to be connected where?
Show me the picture. Wait, what?
From where to where?
From the collector.
Yes.
That means from the plus of this one from here to the base.
Okay. But you don't know which one is the base, or you are not sure.
Yeah.
So which one is the base?
We have to check which one is the base.
Yeah, check.
0. It's OL.
Okay.
That means that's the base.
But you sure the base is driving with the collector and emitter? I didn't see you to check. Okay, and emitter? Yes. Okay, that's the base.
So that's the base?
Yes. So you have to solder the resistor.
Oh, but that's easy. I have to solder right here, like this.
Yeah.
Let me short the legs.
Let me help you. 1 second. Yeah.
Thank you.
You need some solder there.
Yeah, I know.
Okay, that's a bad practice. Listen, that's a bad practice because from the moment you take the solder till you move the solder iron there, the flux evaporates. Remember, this has a core with flux inside.
Okay.
You know?
Yeah, so, should I put it like this?
Yeah, like that. Yeah, great. Yeah, that's all. So now we need what? The diode, right?
Yes.
Okay.
Not the diode, the Zener diode.
The Zener diode. Okay, so the Zener diode, obviously you choose the Zener diode based on the voltage you want on the output, yeah?
Yes.
So what output do you want?
12 volts. 12
volts, it will not really cover your needs. I mean, the voltage get dropped with the light bulb down to what? What was the voltage, like 14?
Yeah.
So how about if I connect 3 light bulbs? It will go under 12, right?
Yeah.
Yeah, so you see?
So we need more.
You need more what?
More voltage.
No, you can't have more voltage. It's a transformer. You can't have more. So your usable voltage has to be under.
So that means we're going to use what?
Like any Zener diode you want, we can use. It just try to make you understand what you can get from. You want more voltage, then you need a bigger transformer. You understand?
Yeah.
We can do it. We can swap the wires here. Remember, here we have like, I don't know, was bigger, higher voltage.
Yes, it was higher.
Yeah. But I'm just trying to make you understand the limitation.
Yeah.
Well, let's see what Zener diode we have here. So what Zener diodes are those? He's saying like 3.3 volts there?
Yes.
And this one, we can read.
Oh, this one doesn't. Oh, it was saying something.
And this one?
This one is 10 volts.
Oh, wait, this one is 8 or something?
Something.
What is saying?
8 volts.
So 8 volts is fine for you?
Yeah, so this is 10, this is 8.
8. Take the 8 volts one. And solder the diode.
Give me the picture.
Just for what?
To see where I can put the diode. From base to minus. Yeah, easy.
That's the plus of the Zener diode, but I think you know already
Yeah.
that. Okay, do it.
That's the base.
Yeah, it is.
Oh, we can do it like this.
Not sure what you try to do.
To put some
But you have.
a bit.
Okay. To where?
To minus.
Exactly.
To here.
Yeah.
To right there.
Yeah. Good.
Whew.
Good.
Right.
So what is the output? Our output, voltage output, current output.
It's from output from minus
Yeah.
to plus this one.
So what's pin is that one?
That's plus. That's plus and that's minus.
That's not plus. That's a pin from the transistor. What's the pin?
Oh, that's the emitter.
Okay, you're right. So I will plug the transformer and you have to check the voltage. Okay?
Okay.
Good. Okay, so check now.
All right. So from minus
Yes.
to plus.
So what's the voltage?
8.2
8.2. Check the voltage on the Zener diode.
on the Zener diode.
Yes?
That means from
Parallel with the Zener, obviously.
here to here.
Yeah?
From minus
Yeah?
to here.
Yes? What is the voltage? You are not touching.
I am touching.
No, you are not touching. Trust me.
8.5.
You see?
Yeah.
Do you understand how this works?
Yes.
Hmm?
Mm-hmm.
Because the resistance, what voltage is where is the resistor?
Where is the resistor?
Yeah, on the input.
From wait.
Obviously, everything what you check compare with ground. You understand?
Yes.
Okay.
So from here.
So input is actually the capacitor. The capacitor
Yes.
is on the input, or the wire which is coming from the rectifier bridge.
To here. To here.
Yeah. So what is the voltage there?
It's 16.
So you see? You understand?
Yes.
So what is the output voltage one more time?
The output one.
Yes.
I need to hold it. It's 8.3.
Yeah, so basically around 8 volts, yeah?
Yes.
Good. Now let's connect the LED. So I'll connect the LED, so you check the voltage. Yeah?
Mm-hmm.
Good. So check the voltage.
It's 8. So
8 volts.
yeah.
You see the voltage is a little bit lower.
Yes.
Why? Why it's a little bit lower? So you checked was 8.2.
8.3 actually.
Okay, so why it's 8 volts?
Because the LED losing some current.
I don't care what the LED
Not
is
the
losing.
LED.
I care about why I have 8 volts on the emitter. Check on the schematic, 8 volts. Why do I have 8 volts? And without the LED, I have 8.3.
Because you lose some current on the transistor. Sorry.
Exactly. Yeah?
Yeah.
So that, or you lose some current on the transistor.
Yes.
Okay?
Mm-hmm.
Good. That means the transistor, it will get
I
hot,
mean,
warm, whatever.
yes.
Good.
At 0.3, what we're losing is not that hot. It's just I don't know if you can feel it. It's not that.
Okay.
No.
Okay. Yeah. Let me connect.
I mean, if you lose more, actually, you can feel it. It will get hot.
Okay. Let me connect the light bulb. Check the voltage. The light bulb is dead.
You kill it.
You burn it.
No, it wasn't me.
So why the light bulb is not working? Yeah, it's working now. Okay, check the voltage.
All right. You're not touching it.
Yeah, I know. You try now.
All right, it's 7.8.
7.8. Why 7.8?
Because obviously here you lose more voltage.
What about maybe our voltage drop on the Zener diode? Check the voltage on the Zener diode. Do we still have the reference voltage right?
You're not touching it.
Yeah. So you see the reference voltage.
It's still the same.
Exactly.
It's 8.4.
So if I take the light bulb, what's the voltage there?
8.5.
About the same.
About the same, yes.
So the problem is, touch this one. Touch this one.
Yeah, you see it's getting hot.
Why is getting hot?
Because he's losing some current.
Okay, yeah. And that's the reason why we have less voltage here.
Yeah.
But basically it's doing the job. Because on the input we have... What's the voltage on the input? Check.
It was 7.8.
Okay, it was without the light bulb. Check now.
It's 7.
But where do you check?
Here.
On the input, I said. In input.
But what do you mean?
There, on the input. Where the power is coming on this circuit?
From the emitter.
No, I think you are confused. Yeah? This, it's a circuit. You see this one? This, it's a circuit.
Yes.
Yeah?
Mm-hmm.
So from where the power is coming on this circuit?
From the collector.
No. How can come from the collector? I think you're... Listen to me.
No,
The circuit of the power is coming from the transformer on this direction from the rectifier bridge.
Yeah,
then it's going here, here.
Yes.
Okay?
Yeah.
And obviously the ground is ground, and that's it. That's the circuit.
Mm-hmm.
But this is the input. You see, this is a wire. It's coming from the rectifier bridge. You have a capacitor. That's the duration. That's the power.
Okay.
That's how the power is coming on your circuit.
Okay.
So I ask you, just check the input power. That's what I'm asking you. Check the input power.
Oh, so that means from ground to this one.
Yeah.
It's 14.
14. And output?
This one is output.
Yeah.
It's 7.9. This is like half.
Yeah, I understand, because you have the Zener diode.
Yeah.
So the Zener diode and this circuit is doing the job, is regulating and stabilizing the voltage output.
Mm-hmm.
You have a small drop
Mm-hmm.
because of the transistor is losing some current. It is a way to make this circuit more precise.
More precise.
Yeah. So how we can make this?
I mean, more precise than this?
Yeah, I want to have the same. I want to have the voltage, the output voltage, to be more constant. You know, because it's changing. I connect this one, I have like 8 point something, right? Or how much it was?
Yes.
Then I connect this one, I have like 7.9. So what is the solution in order to make this more precise?
But you have different, because those are like
Different loads.
different loads, yes.
Yeah, but I want, it doesn't matter. Yeah, so that's not what I'm looking for. I'm looking to test, with the same things, but I'm looking the output voltage to be more stable. So what is the solution on this case?
More stable.
Yeah. With this one, we have 8 volts. With this one, we have like 7.9. I don't want that. I want to be exactly 8 volts, even with this or with this.
I have no idea.
You have no idea.
No, I would say to put another center diode, but it's no point.
Center is doing the job. You have like
Yes.
8.5 there.
Yeah.
You missed the point. Why that happened? Why the voltage is changing?
Because you lose some current on the transistor.
So what's the solution to get more precise voltage of the output?
Oh, wait. I think I know. Instead of transistor,
Yeah?
use the other thing. Oh my God, I forgot how to say. Use the. It was the same thing, but it has the same 3 legs, but the base is not the base. Is the drain.
Okay, the MOSFET.
MOSFET. Oh my God, MOSFET.
Yeah, you are right. The MOSFET probably will do the same job, but I didn't think that far.
So there's another way.
There are many ways. A better transistor. How about that? A better transistor. It'll do the job? A better transistor?
Do you mean more powerful?
Yeah.
It will do, yes.
So does mean a better transistor can carry more current, you'll have the internal resistance lower.
Yeah.
So does mean the output voltage, it will be more precise.
It will be, but it will still
Okay.
It will still be the difference if you connect a LED or a
What about if I connect 2 transistors or 3 transistors on the parallel? That means 3 base together, 3 collectors together, 3 emitters together.
There will be a lot of work.
I'm not speaking about work. I'm speaking about ways how can I make the output voltage more precise. Because 3 transistors in parallel, that means like 3 resistors in the parallel mode.
Yeah.
That means the total resistance, it will be lower.
Lower.
Right?
Mm-hmm.
So I will have more precise output voltage?
Yeah.
Yeah, I will. And actually, you will see this kind of configuration with many transistors in the parallel mode, probably like everywhere. Even this power supply has like 2 transistors in the parallel mode.
But it's not simple to use a MOSFET instead of a
It's
transistor?
not that big difference. It's not such a big difference. We can replace this now with a MOSFET. It's not that big difference.
Okay.
I mean, okay, like the resistance probably is like half compared with a transistor, but it's still. You understand? It's not such a big difference.
Yeah.
So you understand?
Yeah.
So we finish with the regulators, yeah? Actually, what you see here is on this power supply, on the lab power supply. Has the same as transformer, has rectifier bridge, capacitor, then has 2 transistors. But obviously, it's not a standard diode, has a complex, board to command the transistor. Yeah?
Okay.
So this from the base has a complex board, adjusting the voltage, the current, and so on.
Cool.
Interesting?
Interesting.
So it is clear?
It is, yes.
You sure?
Yeah.
Okay, good. So in this case, we're gonna stop now.
You sure?
Yeah.
I would say.
I'm hungry.
Oh, that's why. Let's run. I will say thank you for watching.
Like and subscribe if you like the video.
And see you in the next one. Bye.
Bye. Wait, I'm hungry.